I had a wonderful elementary teacher called Gino Conti, and he just made it wonderfully fun. This is monofilament and aluminum ferrule, and so that make little bands that are the right length to build things with. I was just sort of amazed that, you could think something through, make it, and then it would talk back to you and basically inspire you to go on to the next idea. I went to school at Kansas City Art Institute, which is very good for an Easterner to go to the Midwest and see what that's all about. It was wonderful. It was really fun. We would go out into the prairie and see the whole sort of great expanse of land. And it's really where I took my rolling icosahedrons and saw them move across the landscape. The ladies that had been responsible for the Rhode Island Women's Pavilion in the Centennial Fair in Philadelphia, and my great-grandmother basically had something on the order of $1,500 left over. They voted between a water fountain and starting a art school, and the art school won out. So that's part of the DNA. And it's sort of extraordinary to be involved with it today. It's really quite a privilege, an extraordinary privilege. Well, actually, the inspiration came from something I saw as a kid at RISD. What they were doing was taking mirrors and water prisms, and you could direct the sunlight through the water prism and then pick it up with a mirror and shoot it up into these glass flowers that they'd made with rods going in every direction. Of course, when it went through the prism, you had colors, and those colors would reflect off of those glass rods. A large part of it is I've got mostly woodworking tools, and you can either cut aluminum with them or you can cut wood. So the process typically is to build jigs out of wood, maybe even build a number of pieces out of wood. Then as the ideas come to fruition, begin to move into aluminum. If it's going to stay outside for any length of time, it has to really be a metal. This is the other part of sort of how I got started doing all this stuff. I made a glass box and put a Coca-Cola bottle in it and started drawing on the outside of that box, the object inside of it. And as I moved around, of course, the shape changed. But what I got fascinated with is the fact that I was moving around and the object was taking on shapes that had absolutely nothing to do with the Coca-Cola bottle's sort of iconic shape. From that, I began to think about, well, what if I stay stationary and the object moves around me? And that's when I started to think about building a geodesic style sphere, because Buckminster Fuller's ideas were very popular in the early 70s, late 60s. And much to my surprise, when I put little sails in it made of aluminum foil, it rolled on the ground with the wind, and it rolled right up the stairs of the Nelson Atkins Museum in Kansas City. So it was sort of like, whoa, you put it out in the environment and all of a sudden it's something magic happens and you're like, I gotta do more of this. So now you're getting to things I'm really sort of still experimenting with, which is how these Platonic forms can be sort of interlaced, tetrahedron, cube, octahedron, dodecahedron, icosahedron. So icosa is 20 sides, the dodecahedron is 12 sides, the octahedron's 8, the cube is 6, and the tetrahedron is 4. What's interesting is that, say, a cube with 6 sides has 8 vertices or corners, and the octahedron has 8 sides, but it's only got 6 points. So you can begin to see there's a correlation between points and sides, and that's why they're duals of each other. And then it gets kind of interesting because in the nano world, which is sort of where our current abilities to manipulate things are, at least for science, and we're building things at that scale. And these platonic shapes you will find at that level. The understanding of the physical world around us just keeps changing all the time. Who knew that we can only see something on the order of 6% of all the matter in the universe? I get really fascinated that I'm exploring these things and then I can find a reference in science to it. It's just plain extraordinary. The other part of it is you see the work of a sculptor like Kenneth Snelson, who sort of invented with Fuller the tensegrity. And you know you're copying these two guys. You're sort of exploring it in your own peculiar way. But what makes it actually more fun is to see that these forms are, showing up all over the place. You want to be careful about thinking you're the original thinker of these things, and it's better just to realize that, you're exploring it your way, making out of it what fascinates you. And at the same time, you can feed off of what other people are doing. I'm not a person that tries to explore an idea to its nth degree. So if I begin to see something that looks sort of more challenging, I'll begin to gravitate towards that. It becomes sort of exploratory. That's more interesting than if I were to make every permutation of something. I'd rather stop and follow the thoughts that come up. But the feedback is sort of it's just sort of one of the real marvels. I mean, when you put your object out there on the landscape and it does something that you didn't expect it to do, it's just thrilling. And then you try and, sort of take advantage of what you've learned from that experience.